For those who have joined, maybe it would be great if you could rename yourself so we can see who has joined. Some of the login IDs are some unique codes. So it would be great if you can rename yourself. Okay, good afternoon, everyone. Thank you for joining well on time. We'll get started with the session today. I welcome you all to this masterclass on systems engineering is automotive DNA. We have here with us a veteran industry expert in automotive industry, Mr. Vishwas Vaidya. I will briefly introduce him before I hand over the floor to him. Thank you, sir, for joining today. And about sir, he has over 33 years of automotive industry experience, both for two-wheeler and four-wheeler, specifically EV system domain. He has worked in various aspects, whether it is automotive embedded systems or modeling and simulation, powertrain, battery sizing for EVs, you name it all. He's an avid practitioner. He has been an avid practitioner of systems engineering all throughout. He has a master's in control engineering from IIT Delhi, and he's a very active Society of Automotive Engineers member. He mentors and he mentors through the spectrum students and seniors. So he's always available to bounce off thoughts and give ideas as well as innovation. He encourages everyone to think innovatively, and he's an exemplar of that. He has 25 plus patents in the automotive domain. So really excited to be hosting this session along with Vishwas sir. About me, I'm Stuti Gupta. I'm co-founder director at Blue Sky Solutions. I also come with extensive systems engineering industry experience, and welcome you all again to the webinar. Over to you, sir. Yes, but I got the promo. You got disconnected. Just please bear with us. Yes, just make sure sir's connection is.
Screen. Very good afternoon. I hope I am audible, correct? And I'm very happy to be with automotive audience who would like to start their system engineering journey? Some of you, some of the, some of you would already would be pursuing system engineering as a discipline, but would like to know more, would like to bring your experiences to the table, would like to share with everybody who is there, and also go through our journey here. So we'll start. See the title, right from the title. System engineering is not just a isolated discipline. It has to be one as an integral strand from each and every automotive activity, like a DNA. That is a point we are going to highlight stress. System engineering will come as a fundamental engineering discipline, which all of you to see each and every of our activity. We have one IT through our DNA, even the presentation which I am making supported by IT. And yes, system engineering is applied not just to automotive professional, automotive engineering discipline, but many other fields, even in many problems in your life, you can have a system engineering perspective. But today our focus mainly is on automotive. So this is the overview. We start with the pain, get hit by pain points. We don't really wake up and then see what is the remedy. So remedy here is system engineering, which would be discussed. And start with pain points. And like a doctor, first what we do is we get further deeper insights into the pain point. Then we can come up with countermeasures, which would be in the form of system engineering. And we will go into various tools, the tricks of the trade, like V-cycle, the requirement engineering, system architecture, system design. Equipped with this string DNA in everything that you do in automotive engineering. And once we are done with this presentation, let us sum up and see the next step, because presentation is only start of the journey. What are the next milestones in our journey? How we can work together? What are the joint possibilities we can have? Those who are know how it is written with conflicting trade-offs, conflicting choices. It is a kind of a paradise of minefield. You don't know which time bomb will go off when. At one hand, you are rising but it is shrinking daily. Every passing year, the amount of time from your drawing board to the road, it's shrinking quite aggressively. And if this is not enough, perpetually, year after year, there is a pressure for cost reduction. I have been in many roles in automotive world, particularly OEMs and tier ones. Every year, even their performance as a metric, the percentage cost reduction plays a big role. So let us review some of the well-known catastrophe, well-known to some people, may not be known to other people. What is the takeaway is the kind of pain point people faced. There was a disaster, automotive disaster, where the electronic throttle which was employed for modern vehicle, this is a kind of decade ago. the whole system would go haywire and the car would start accelerating without pressing even the throttle. And even when you are standing on the brake, the vehicle will wildly go on accelerating till there is a fatal crash. And this is kind of coming back to full circle when the carts were pulled by horses and horses go insane midway. There is no way you can stop it, and the only way available to it is a fatal crash. Similarly, the intelligence which was put into the vehicle proved like a double-edged weapon. This is the pen point number one. Pen point number two is see, I told you about cost reduction, and for doing cost reduction, again there is a pitfall. You can reduce the cost, but at what value? That is important. So, in my own personal experience career, there was a suggestion that to reduce the cost of a side mirror, you can just remove the text. Objects in the mirror are closer. But then, luckily, fortunately, through our joint discussion, we shot down that idea because this is not a cost. It is a value, life-saving value, which I am adding to new drivers, to other drivers. Okay. Then another very frequent phenomena, if you read the newspaper, technical magazine, electric vehicle magazine, even the global brands, globally reputed brands, we find that we find the batteries are burning. Batteries are burning and entire vehicle burns. And then people start investigating, and many times a blame game starts. The battery vendor will point out at the integration team. Integration team will point out battery, both of them may point out at battery management system. The starter motor is another another time bomb kind of thing. Another weak area. The starter motor, you can see, it's a small starter motor is able to drive a very big engine. Those interested can go to internet and see the interesting story of invention. Yes, it is a very small starter motor which is able to drive a very big engine. This is all fine when engine really starts successfully. But if engine doesn't start due to any reason, say discharge battery, and you go on cranking it, over cranking it, the starter motor is the first element to burn, and it constitutes one of major field reduction, field problems in electrical electronics domain due to abusive use cases. This is another pen point. So I have only selected top few pen points because of the constraints on time. But having understood this pen point, let us see what kind of system engineering lessons we can see. And uh, any OEM which is launching electronic throttle in a global market actually is equipped with many simulation tools, many testing tools, okay, many emulation tools, and still this has happened. Why? The tools are not enough. What should be there is a system engineering mindset. What is system engineering mindset here? Every component subsystem in vehicle is a like double-edged weapon. You can get a technology, but the technology, if not used properly, is going to backfire at you. And that time, for the study possible culprits, somebody from OEM said our carpet was overlapping. Oh, if the carpet is overlapping, then why a person who's standing on the brake is not able to stop the vehicle? That is a question to be answered. The software bugs, EMI, so many other things. So vehicle is accelerating uncontrollably, and really the all occupants are helpless. There are YouTube videos. So what is the system engineering lesson here? The person who is integrating the vehicle must have a bigger view. When both brake and accelerator commands are active, we have to honor brake command. Now it sounds simple when we see this. But when you are developing, you are deep into component development, the electronic throttle developer will focus only on throttle. He says throttle is pressed, I will do it. Brake developer will only focus on brake. But when both are active, there is no taker for that. The baby is left unattended that time, and that is what. So that is the uncontrollable horse cart we described. Similarly here, see, when you talk of a mirror, you cannot talk of a mirror in an isolated way. Hmm. Mirror is a part of larger ecosystem of which one driver is a part. Hmm. Like a mirror is a component, driver also is a component in this ecosystem. So you fiddle with component A, which is mirror. Component B, which is driver, is going to face fatal consequence. Hmm. He or she may not be able to judge how far the objects are if that is removed. Even the experienced driver sometimes under panic may forget. So this is a very vital and potent reminder during panic driven traffic situation. Hmm. So this is another system engineering lesson and pitfall which luckily that time through um, in-depth discussions we were able to do it. Hmm. Actually, electric vehicle, I always tell my students, is deceptively simple college project. How? Because the battery hmm, has to be pampered like a child every second. Every second you discharge or charge battery has to follow a particular set of prescribed rules, prescribed profile. And if you don't do that, hmm, nothing may happen for first few months. Like a college project, on the day of demo, the vehicle really runs well. Hmm. But if you have violated so many prescribed precautions by the battery vendor, the BMS vendor, battery is slowly aging. It is like a young college boy smoking 50 cigarettes a day and he enjoying his life. He may enjoy his life for a few months. After that, he will face the music. The same thing happens with battery. When not taken care, then battery may burn after a few cycles, after few months, few years, or its life, less fatal consequences, its life is over prematurely within an year, whereas 8 years are there. But that also can be fatal if midway in your traffic, your battery throws up its hands. So battery management system, battery traction system, vehicle controller, all of them have to really deliver conflicting requirements. On one hand, you need aggressive pickup, thermal stability, long service life, and fast charging. On the other hand, you want battery to stay alive, not just alive, stay strong throughout the service life. But if you plan any shortcut, bypassing any of the requirement, you may be happy for first few months. But at the end of first few months, you can face the fire, literally. The starter engine. Actually, starter motor was invented early 20th century. And it is really a guiding beacon for fuel engineering innovation because it is based on the idea that an electric motor can digest 10 times more inrush current than its continuous capability, and that is where it is able to start the engine within a few seconds. After those few seconds, you switch off the starter motor, allowing it to cool. Because in starter motor, the conductor, copper conductor doesn't melt when it gets hot. What may get damaged is insulation. But that may take thermal time constants of several seconds. That is the starter motor to kick off very large engine. But then this is the engineering pitfall here. You have to win the competition. You have to do the mass production. So we end up cutting corners and the design margin is compromised. And many low cost vehicles which I have come across suffered from this inadequate margin, and you may produce a few starter motors in a day well, but the moment your number increase thousands a day, it is very difficult to meet those margins, and what you have is the fire due to inadequate margin, fire in the field. Now I think concepts Stuti will really take over for some time.
All right. So that was just the start of the real life, stories, case studies, experiences that, Sir has planned to share over the, entire content of the session today. So hold on. There's many more real learnings and how systems thinking could have helped in addressing those if thought properly. So for now, I'll just launch a quick poll. Would like to know a bit about the audience. So I'm just launching the first poll. So here, the idea is to just know your familiarity with systems engineering. Are you actively practicing systems engineer? Maybe you're a little familiar, you've got formal training, you've studied yourself, or you've just heard the term from your colleagues, or you think there's something going on in the organization regarding systems engineering and you're here to learn more about it. I hope everyone can see the poll on your screen. Sometimes if you join from browser, it may not show up, but more often than not, okay, I'll have it up for a bit. Okay, excellent. So it's great to see that we have quite a mix, and this is something we will also leverage in our breakout session towards the end, where we have a great mix of those who are actively practicing and those who have been very honest and said that they have only heard the term. And I'm really glad you chose this forum to get yourself familiarized about systems engineering and the value of systems engineering. So I'll end the poll now. There's another poll I have, and this one specifically is on model-based systems engineering. So for those who are practicing systems engineering, are you already using formal tool environment, or you are, sort of more traditional way of systems engineering, and that's also okay. Um, okay, thank you for your responses. Ken, it's a great mix. So with that, we'll get on with the presentation. So just very briefly, to set the context for the rest of the discussion that Sir is going to walk through, just wanted to establish, what we are referring as a system. So if you look at the formal definition from ISO 15288, it is a combination of interacting elements organized to achieve an objective that you are creating that system for. Or you could also say that it's an arrangement of the components or the elements, entities that together will exhibit a behavior that you would that you desire. And if we see that individually, you wouldn't individually those components will not be able to exhibit the behavior that you desire. It is only when you bring them together, you integrate them, right? So that's sort of the formal definition of the system. So in terms of how to characterize a system, you should if you are describing your system of interest, or if you are understanding a system of interest that you might be participating in, look out for these characteristics. Like a system should have a structure, that is, it is made of system elements. Those elements will have different attributes, as simple as the dimensions, the weight, the overall volume they may occupy, the system may occupy, and so on. And then it has an intended behavior, that is, it has a function, the functionality that you're designing it for. It could be present in different states. So for example, when we talk about vehicles, it is in parking state, it is in completely shut off stationary state, it is in driving state, um, and so on, right? So there are different states of the system. There's a boundary. So if we talk about vehicle, then considering our vehicle as a black box, it is at the center of let's say how I'm visualizing it, and there's a boundary around it. So it's the boundary essentially gives you a differentiation what is in your purview and what is outside of your purview. But your system is interacting with things that are outside your purview. So the boundary essentially establishes that. So there are entities present in the environment in different operational scenarios, in different contexts that your system is going to interact with. And such a visualization helps bring an appreciation of how that interaction is happening, how across the boundary you need to consider some interfaces, right? For example, if your car is very smart, it is connected car, then it is going to be interacting with some internet service provider, or if it's an electric vehicle, then it's going to interact with the charging station. You are not the one who's designing and developing the charging station, but you need to interact with the charging infrastructure, and it's being managed by someone else. So sort of your vehicle is in the boundary, and all of these things, the user, the passengers in the car, they're all outside the boundary. And it's also a strategic decision sometimes what you want to consider within the boundary, right? Every system has a life cycle. So we all know that we'll conceptualize it, we'll design, develop, manufacture it, and then you will commission it, or it will be in the utilization phase, it will have a maintenance stage, and then ultimately at the end of life, there will be a retirement stage. The other thing is also to understand the context, because as I was describing the boundary, the system, you know, exists in or is going to operate in different environments, and you need to consider on day zero. You need to consider what all those possible environments or contexts that your system is going to operate, so that you can factor the needs from those contexts. Maybe some stakeholders or users appear in a certain context only. For instance, in the usage cycle of the vehicle, it's only in the service context that the technicians will appear, and they are interacting with your system. Maybe they are through the diagnostic ports or some other regular maintenance activities. So understanding in what are the different contexts or environment that your system is going to operate in. And then there is an emergence. So obviously any function that we are designing for is also an emergence, because you're putting all parts together and there's an emergent behavior, but that's a desired and a designed behavior. Emergence is generally viewed from the point that over a period of time, there are certain other behaviors that you start to observe which you did not do so on day zero. For instance, your car may started to be utilized for something else which you had never imagined it would today. Okay. And then that was to establish what is a system, and as you define or you are learning about some system of interest, that you look out for those characteristics. And as we go more deeper into the entire systems engineering process with lots of industry examples, just want to establish the formal definition of systems engineering, which is it is a transdisciplinary and integrative approach. If we look around all the systems that we are working on, the the boundary between the different disciplines is blurring, right? So that's what is, and you can see for the aid of understanding, I've kept a picture in the bottom where you can see the transdisciplinary is many disciplines coming together. And the whole purpose and value of systems engineering is to bring all of these disciplines together and have an integrative approach to realize these engineered systems, to design these engineered systems using the formal systems principles and concepts. And they are both technological and management methods. It's a mix of both. Yes, as a systems engineer, we largely wear a technical lens, but again, we need to manage all of the activities that we are doing in terms of the technical development. So with that, I will hand over back to Sir, who will talk about yet another interesting case study.
Yes. Now we have gone through the foundations, definitions, basic nuts and bolt. Hmm. Let us review a very interesting case study. Hmm. How a top level experience, a top level problem faced by a person who is driving the vehicle can be traced down through systems, through subsystems, through components, through subcomponent, down to the last subcomponent. It was a sedan class of diesel passenger vehicle, which was actually for 4 or 5 years given a successful market run. And after 4 or 5 years, there was an interesting field problem where people started reporting loss of pickup accompanied by black smoke from tailpipe. Particularly diesel vehicle, when you want to launch, you need very good starting torque. Diesel engines by their nature are sluggish. And here, whether you want to overtake or you want to start, instead of giving you the torque boost, it was giving black smoke. And you could feel the loss of torque, a loss of pickup. So like a time bomb, it started spreading throughout the market. Okay. And this problem actually, those who are into uh, automotive engines, I will briefly explain that in diesel engine, for controlling the pollution, you mix exhaust gases with the fresh air which is going inside. Exhaust gases being inert, they tame the combustion process and bring down the combustion temperature, which in turn discourage or arrest the oxidation of nitrogen, NO2, NO3, NOx. But the flip side is, even though you win on pollution front, you lose on torque and pickup front. So this is where electronic comes. Electronics judiciously monitors driver wish on the one hand and other sensor information on the other hand. And if driver wants to overtake somebody, you go easy on mixing of exhaust gas, give benefit of torque to the driver. If driver is only coasting the vehicle, you mix a lot of exhaust gases and arrest the pollution. This is how throughout the driving cycle, electronics plays a balance rope trick. Balancing rope trick. Okay. And what we had done to refine the vehicle behavior, like many times you find that if air conditioning is on, the vehicle cannot take pickup, or some other engine based load is on, or you are aggressively demanding torque, engine is not able to give it. And we had a small electronic unit which would dilute EGR circulations, exhaust gas circulations, so as to give benefit of torque to the driver under these critical conditions. And this electronic unit was assessing many such conditions: vehicle speed, engine speed, rate of pressing of throttle, engine temperature, so many things, and making a decision: should I increase the exhaust dilution or should I disable the exhaust mixing? Hmm. So uh, all of a sudden it started misbehaving, this electronic unit. If you change it, it is working. So now you can trace the problem started from the driver at the top level, loss of torque, black smoke, came back to the engine system, which is system number 2, came back to the EGR system, subsystem number 3, and came back to the control system, subsystem number 4. So the boundary is going on reducing to the control unit, small control unit. And in that control unit, when we went deeper into circuit, a particular capacitor had started behaving like a resistor. Hmm. Like a 1 kilo ohm resistor, it was behaving very, very abnormal. In our entire career spanning decades, we had not encountered such thing. And since it had become resistor, what was happening is the entire decision logic was getting fooled, and it started misbehaving because the decision is based on incorrect equation, incorrect input. Obviously, when you want to really suppress the mixing of exhaust gas, you are ending up doing exactly opposite. That was the reason why it was happening. Now, see, we have started again from system engineering point of view. From the top, requirement of driver needs to have torque with less pollution. Hmm. Then came to engine, then came to exhaust gas recirculation, control system, circuit. In the circuit, the last component is capacitor, but the story has not yet ended. Why should capacitor start misbehaving after so many years? So then this was traced back to the dielectric vendor of the capacitor. The dielectric vendor, without informing anybody, wanted to go frugal, cost reduction, I told you. Like the earlier case, somebody wanted to wipe off the letters on the mirror at the cost of driver. Here, he had done uh, econ. He had done the um, frugal engineering, uh, cutting back of material, conserving the material, material to reduce the cost. All the tests pass, all the test will pass. But when you go to the road and drive it for a few months, its life has come down. Its life has come down. Not only that, it starts leaking in a such a way, it settles down to be a resistor. Capacitor turning into register after 6 months of operation. So we had to change the vendor and remove the capacitors. That was the problem. That was a separate headache by itself. But here it's a very, very valuable system engineering case study where how a small decision of conserving the dielectric area, dielectric volume can impact a driver vehicle behavior, adversely impacting a driver. It may lead to accident also. If you want to overtake, you are not able to overtake. And now, see, people say that we have been practicing system engineering quite well. So I was really surrounded by such, our team was surrounded by such people who profess to be practicing system engineering. Professing that I practice system engineering is one thing, but when you are really into panic situation, sticking to that tool with a patient mindset is quite another. The people started saying we should change the circuit, we should change the entire system. They are blaming without really resorting to system engineering approach. Those who said circuit is to be changed, our question was simple: why it was working so many days, and if at all it is my capacitor choice is not correct, which specification am I violating, because of which I need to change? Unless you answer that, we are not going to change the capacitor. And by putting our foot down and sticking to system engineering principles, we were able to conquer the problem in a very short duration. So supplier tried to cover it up, is goof up. And when all these naysayers, they are confronted with simple question, I said, tell us which of the public specifications of capacitor we are violating. So it is all the it all boils down to asking the right questions in line with system engineering discipline. And then only act when you are convinced with the right answers. So of course they could not point out a single parameter which you are violating, and that is why it was working all these days. Something has gone bad now, something has gone amiss, and this question was supported by detailed analysis also, value requirement, and then we were able to trace down, he had to admit that this is what has been done. Now we go into V cycle. You are taking.
So isn't that interesting that as simple as a capacitor in dielectric area, and we're looking at the vehicle behavior over a period of time, right? So definitely each one brought their expertise and took decisions at their level. However, probably what was missing, as Sir pointed out, that the systemic thinking, that I made a decision at the layer I'm participating, but failed to trace it to how my decision is impacting the overall behavior of the system, and I would only know it once the system is in operation or use in its context, right? That definitely leaves for an unhappy customer. So it's very important to establish the connectedness and the traceability through the V. We are all probably, I'm assuming that a lot of us in this group have already seen V cycles. Many of us are already participating in this V. So while we, when we are in new product development, NPD projects, then definitely we very religiously would start from the top left of the V, where we are understanding customer needs, which are fuzzy and ambiguous. We are exploring different concepts that can satisfy those needs. Then as we come down the V, we are looking at establishing a better understanding about the high-level behavior of the system, where our system of interest is still a black box, and then use that information to translate to good system requirements, create high-level design, get into detailed design and implementation, and then logically again walk back upwards on the right side of the V, where we are doing verification and validation. And then, of course, commissioning, or our system gets introduced into its operational context. So if you see, what I just sort of articulated is, it could be equivalent to just a flat stage gate process. However, it is not flat at all. What we need to consider is, while we are concepting, while we are exploring concepts and having a high level understanding of the system, at that same time we start to build a system validation plan. How are we validating it? How are we making sure that what we have, what we are planning to build, meets the customer needs or not? Is it the right system that we are building for the customer, or for the requests or the wish list that the customer has said? And then as we start to articulate, do elicit requirements, and derive, make different derivations of those requirements, we start to establish a good verification plan for those requirements. If any requirement statement and satisfying that requirement adds cost to your system, right? Because you, to satisfy the requirement, you would need some solution, some feature to satisfy that requirement. So how are you going to verify whether that solution meets what the requirement is stating? And you would not look at one requirement statement individually. You will look at the entire set. You will have to look at how different requirements are dependent on each other, or influence what decision that you make, or in terms of the solution that you would choose, how does it impact the decisions that others are also making? So there has to be some set of traceability that you establish, and also not only in the hierarchy, but also in terms of the left side of the V and the right side of the V, that you ensure that there are no orphan requirements, that all requirements are getting verified. And for each of these, what I mentioned, there are several formal SE methods. What you see on the screen is not an exhaustive list, but some of the methods, for instance, trait space analysis, or having a very high level system model. Like for the last example that Sir shared, maybe if there was a very low fidelity model, we could even ensure some of those impacts during the usage of the system itself. There is ConOps, there is context diagram. All these methods are available to establish and document a better understanding of the system. There are many times we work on legacy projects and we inherit those with very minimal documentation. What does that lead to? That leads to making our own assumptions that why this decision was made, and we add solution over and above those assumptions that were made in the past. But if we have good documentation, we can definitely relook at the original purpose or the original intent why a certain feature or capability was provided in the system. So the top part you can consider as the solution, the problem domain, where you are still exploring. You're not sure what solution is going to be provided, but you are trying to be ignorant of what solution already exists and trying to see if you can bring in innovation to satisfy the same set of requirements or a new set of requirements that you have received. In the bottom of the dashed line, which is the lower part of the V, that's where you actually start to build more detail about the system. So once you have the system requirements, you'll derive it for different functions. You will use functional architecture. You'll sort of define a functional architecture. You'll use design structure matrix, interface control document, trait space analysis at that level, both at functional and physical architecture level, to ensure that the choices that you have considered all the choices in the design space, and that the choice that you are picking, you have a high level of confidence basis the trait space analysis that you set up. So the bottom helps answer the question, did we build the system right? And the top part, as you can see, where you are at the problem domain, is essentially helping you answer, did we build the right system which meets the customer requirement?
Okay. Okay. So many of the systems, they are software driven, but before we reach the software, this is the overall system personality which we have to take care. Have we tailored the system personality to match a given deliverable? That is how we drive the entire system design cycle. You start from the user requirement, and before going further, you can verify those requirements through several test cases, through brainstorming, debating, thought experiments, and whether these requirements really make sense. Like a requirement that nothing should be seen on the mirror, no text should be put on the mirror, will not be accepted, come back, because it is impacting safety of the driver. With that, you come one level down and have a logical system architecture. The requirement to be which are to be implemented need some logical system to execute those requirements. So you have to specify various logic blocks to implement those requirements, and that also you subject to some test cases, maybe through simulation, through rapid prototyping, through paper exercises, and come back for early revisions. Any design revisions you are able to encounter early will consume very less cost, very less engineering man hours, and very less impact on your entire vehicle life cycle development cycle. And that is how this V cycle will help you. So every stage as you go down, the left side you are into design, whereas the right side keeps checks and balances through implemented through various tests, assessment, and make sure that you are not deviating from your goal, you are not coming up with a lot of undesired costs, reworks. That is what the right side says. What left and right join their hands together and go down the steps to deliver you the in products. The top ones are system development. So after logical architecture, you come to the technical system architecture. A logic block to be implemented could have many technical choices for implementation, like that EGR control. We chose an analog circuit over the digital ECU for some um, refinements, for some design refining some rules. So there is a system development. At the boundary of system development, your system personality is frozen. Now this system personality needs to be equipped with the software, soul of the software. And the software will really pump life into the entire system. So you first specify the software architecture. That architecture also will have a lot of choices for implementation. And those decisions you can subject to various test cases. You can go into simulations, MATLAB Simulink, your UML implementation, and revise, optimize your architecture there itself. Then you specify various components in the architecture, software components, and individual components also can undergo tests. And then you design and implement each and every component through the road. So this is only a real life experience. I will not go into detail, but the takeaway from here is that everything which you do in life can be looked at from system engineering life point of view. Another very, very interesting case study. What was the problem statement? That we have to improve fuel efficiency of all existing vehicle variants on road through micro hybrid feature. See, people say that fuel efficiency can be effected to various means, but what about the business case? Those means for saving, say, 2% of my fuel cost, I end up increasing 20% of a bill of material cost. Nobody will go for it. So this is again a double-edged weapon. You have to improve fuel efficiency, but your bill of material cost increment should be so minimal, it has to justify that saving in fuel. So micro hybrid is start-stop feature another way. Another word for it. What does it do? If you are idling during traffic jams, during traffic intersections, signals, planned and unplanned halts, if you keep on idling, engine is at its worst efficiency, it keeps on eating your fuel, keeps on guzzling your fuel, and you end up paying large fuel bill. Okay. So the real solution is that driver should switch it off and switch on when you are required. But this can be so tiring in your back to bumper traffic. And every time you crank due to vibration, you really feel the jerks. So what you do is here provide an automatic system, automatic logic in some small electronic control unit, low cost electronic control unit. It only looks for your idling condition. Idling condition persists for a prescribed limit, say 5 seconds. It switches off on its own without disturbing the driver. Whenever driver intends to drive back, all the driver has to do is to press lightly his accelerator pedal or brake pedal. That is prescribed. The vehicle starts again. So with this, without lot of fatigue, adding lot of fatigue to the driving operation, you are able to conserve the fuel. It seems so attractive that only minimal low cost hardware and low cost logic, we are able to increase the fuel efficiency by say 5% across the platforms, and the entire arithmetic was looking attractive. And for 3 years, the team really slogged and made some prototypes working. Everybody was very happy. And then they said, let us have a batch of 100 vehicles. So now we started going to key subsystem vendors. We went to starter motor supplier, saying that, please give us 100 pieces of starter motor, a new vehicle feature getting tested. Then he asked, what is that feature? We told him that your starter motor will go on and off at every intersection. And he said, sorry, I cannot do that because the number of times during the starter motor life it can go on and off is limited and not designed for this kind of frequent on-off cycle operation. If you want that, give me 3 more years and my development cost, I will come up with slightly oversized and more robust starter motor specifically designed for this kind of usage cycle. Hmm. People were taken aback. Then they went to battery person. Can you give us battery? Said no. The repeated inrush of current into starter motor, the repeated heavy discharge, aggressive discharge from battery is not something my battery is really designed for. We never foresaw that you would be using it like this. This battery will not serve your purpose. I will refuse to give you my run-of-the-mill battery. It will require a special deep discharge battery. Give me 3 years and so many crores of rupees. So with this, the entire project had to be stopped. Management already spent many engineering hours and a lot of consulting fees, a lot of prototype fees, and entire money went down the drain. Okay, but there are some very valuable lessons for all of us here. Where did we go wrong? So if you see the V cycle, yes, user requirements were done, user requirements are correct. Yeah, I want to reduce the fuel. No two opinions about reducing fuel consumption. Where the opinions may differ is the amount of bill of material cost increment you have to face, and for which you have to treat this as a redesigned vehicle, and each and every vehicle aggregate. You have to reassess whether the can you reuse and carry forward the old aggregate or do you want to redesign? So here the entire system boundary has to cover entire vehicle, not just your engine switching or switch on, switch off and ECU. And that is where the 2 steps which went wrong, we did not do it and focused our boundary wrongly at a very narrow component level. And after 3 years, we had a hard lesson to learn at a very huge cost. And we could not restart. This is only the 2 aggregates. Had we gone to driveline person, had we gone to engine person, he would have told us the same thing, that our engine is not designed for this, our transmission is not designed for this. Okay. So this is where we come to requirement engineering. So in all our earlier examples, what really went wrong were the requirements, right from requirement. A requirement is a statement which expresses expected deliverables by diverse stakeholders under driver's scenarios. The stakeholders, the driver is number one stakeholder. Other stakeholders can be quality per team, sourcing team, marketing, everybody. It can range from abstract high-level management, high-level abstract statement of a service or a system constraint to a detailed mathematical function specification. For example, micro hybrid. The requirement will, the top level requirement are 2. I have to reduce the fuel at minimal bill of material cost increment and at enhanced comfort for the driver. Okay. So then we have to come down. So this is inevitable as requirements may serve a dual function. It may be the basis for a bid or a contract. Therefore, it must be open to interpretation. So that is what happened in micro hybrid. Since requirements were wrongly framed, and nobody worried about impact on the entire vehicle, where the battery person also is a stakeholder. The starter person is also stakeholder, and others we did not even approach. But the engine, everybody is a stakeholder when you are changing DNA of the vehicle. It may be the basis of contract explained and it must be defined in detail. Both these statements may be called requirements. Another very interesting example. This is for a tractor. We had an electronic monitoring display on a tractor. But the tractors, they come up with many farm implements, and these farm implements need careful operation by the farmer who is riding the tractor. It has to control the speed of the farm implement which is plowing the farm, and at different tractor speeds. So there was a Bluetooth based electronic unit monitoring revolution per minute of the farm implement, and on the farmer's cell phone the display was there. Accordingly the farmer was able to control the speed without looking back. See, this is where requirement. The OEM said my requirement temperature is minus 10 degree to 85 degree. And they also prescribe what is the volume footprint and dust, water, mud, ingress protection, because in farm you would have abundant mud, water, dust, everything. And so I cannot have holes in the enclosure. My entire enclosure should be watertight, mud tight, dust tight, everything. So the heat which is generated inside was coming out to be so large. So I cannot really fulfill the requirement of low volume footprint given by prescribed by the OEM. It was coming out to be an impossible design. At the feasibility stage itself it was failing. Because 85-degree ambient was coming to be an unrealistic kind of a requirement. And then we asked, where do you really, we went back, this is where you have to manage the requirement. So in common sense, you imagine yourself as a farmer, and you can imagine where exactly this 85-degree will come. Everything is open to atmosphere. If it is 85, how farmer will survive? Okay, so we went there, went to the OEM who has specified, and he said he was meaning 85, which is deep inside the enclosure, not outside. Then we told him, you forget inside, leave it to us. Outside, can we take it 55? Worst case in the desert. So it's fine. So with 55, our life became so simple, we were able to do it. So this was the requirement bug which we could fix very early. Whereas our competition had lost the project because they flatly refused. They said this cannot be done, and they lost the business. Where this 85-degree really comes, because this is what those who are involved in interaction with OEM, this 85 figure will be very familiar to them. 85 is relevant. At some cases where you have a closed cabin and at an area which is generally never accessed by the driver, somewhere where in the corner, it acts like a furnace. It is standing in the hot sun. It acts like a furnace, and there is no escape route for the heat. It goes on increasing till 85. So when driver even enters and starts the vehicle, at that moment the temperature is 85. But not on those areas where driver can touch. So this sanity check is important. This is the tractor kind of thing. Whether 85 really makes sense, it was not making sense. So we come to the system architecture and system design. There are various tools. You start with the requirements and link it to the next implementation level. Like the EGR case, we started that driver would like to overtake, like to have a torque without impacting on pollution. From that, we came back to the capacitor dielectric. Similarly, here you can see the right side, you have vehicle being designed, and left side that accommodate power unit. It has to accommodate power unit. Car will be powered by a petrol engine. If the research proves to be economical, or electric if that proves to be economical. Now this economical itself will have a lot of requirements, but this is how you convert requirement into architecture. So we will go to a drivetrain requirement. Let us take an example, system engineering example. How will you design a drivetrain? Drivetrain is for a vehicle, and we want to go from point A to point B at high starting torque. Why do you need high starting torque? Because with high starting torque, you can launch vehicle smoothly, even though it is heavily loaded. And also you will be able to merge with the mainstream traffic in a very less time. It must have agile response. Okay. Actually, electric vehicle is pleasure to drive. Why? It is agile. The way you move, your accelerator pedal, it is a 1 foot vehicle actually. Like you dance with your footstep, the vehicle also immediately dances, like a compeer in an orchestra. He moves his wand and the entire orchestra responds in an agile manner. That is what electric vehicle behaves. And you need actually agile response from vehicle as a driver. Then minimum intrusion in reduction of cabin space. It shouldn't happen that the drive shaft, which is going all the throughout the length of the vehicle, it's into cabin space, usable cabin space, then your real estate for using the vehicle is getting impacted adversely. Then steering response also should be smooth and easy. You should be able to steer the vehicle like a toy, like a toy bicycle. The way moment you turn, it turns. Then braking and acceleration also need to be very smooth. These are kind of ideal wish list. What you have is a compromise of all of them. So then various architectural decisions. Should I go electric? Should I go IC engine? Decision number one. Only few key decisions have been taken, but actually the list will be tremendous. Rear engine, mid engine, or front engine. Decision number two. Like the decision number one has given you the propulsion unit. Decision number two has given you the placement decision. After doing that, what will you drive? Rear, front, or four wheel? Another one. And then you come to transmission choice: manual, AMT, automatic. What do you expect from a propulsion? If you see all of these, you need high energy density, which translates into long driving range. Then minimal running cost, low maintenance, long life. I am going clockwise. Then high power density, like strong acceleration performance without using a overly large engine. In smooth launch, high starting torque, agile responsiveness. I will not go into automotive engineering theory, but you can see the pink decision boxes, how the engine and fuel is behaving. So only in the long traveling range, engine is scoring up. All other things, motor is really scoring, and motor is an ideal prime mover. Motor is an ideal prime mover, like your fan. Do you need to start the fan? No, you switch on the button, it starts. That is how a vehicle should be. You press the button, vehicle should go zoom. That is how electric vehicle scores in many of the aspects. Now you want to place, then you decide which one you need for your target segment. So performance are access for maintainability, intrusion into usable space, passenger space, agility for braking. So we have front, mid, rear. Again, I will not go into automotive engineering. Those who are well versed can make sense of the marks which are given, because during braking, say, weight shifts towards the front, and hence front engine vehicle loses traction. Whereas the rear engine, that's why for racing car they use rear engine. Then you continue further, placement choices, again acceleration, steering performance, and driving skill needed. For front engine and front wheel drive vehicle, a run of the mill average driver can drive it. But rear engine vehicle, a racing driver skill is required. Of course, the performance also is so agile that for racing car that makes sense. Then choice of driven wheels, again front, rear, and four-wheel drive. So we have again the marking system there. For city driving, actually what it comes is front wheel drive is good. For rear, it is racing. Four-wheel maybe for off-roading. And when it comes to transmission, you have three choices: auto, automated, manual, and manual. See, automated will give you largest comfort, but torque interruption is another thing, where the clutch breaks your top flow of torque and you sense a discomfort. The automatic can make sure that that discomfort is as minimal as possible through agile operation of electronic control. AMT will come next, whereas manual, unless you are a very expert driver, it is very difficult to smoothly switch the gears without vehicle feeling the torque interruption. Actually, whether driver is skilled or a novice, you come to know every time he or she switches the gear. The fuel efficiency for an expert driver, manual scores the best, auto manual also, because as a driver making a decision, he is able to predict the traffic. He can see the traffic conditions, the pitfalls ahead, potholes ahead, and make early decision for switching the gear. Whereas the automatic can only see the vehicle speed and engine speed. It is a poor decision maker as far as switching of the gear is concerned. City car architecture, you can see from the public domain, you have taken the Nissan Leaf. architecture where a single electric motor is there and a battery is there. A city car will need limited driving range, but agile motion response to navigate through dense traffic. Hence, electric motor is chosen as propulsion prime mover. Then for a city driver, front wheel front motor drive ensures ease of driving. A significant agility in braking and acceleration not required like racing car application. You are only driving in the city. So city car further electric vehicle automatically comes with a single ratio transmission. So electric vehicle doesn't need really any transmission gear. And it has a flat torque characteristic. A city driver front wheel front motor ensure ease of driving. Even the beginner can comfortably drive. Significant agility in braking and acceleration not required like racing car. That is why we go for electric vehicle for a city drive. Then how do you view a system engineering DNA? Those who are practicing automotive engineers, they would know. In every sphere, whether it is a system development, cost reduction, innovation and knowledge generation, future technology roadmap, quality and field problems, manufacturing. System engineering is not just a choice, it is a DNA. It is a way you should take every breath of yourself during your functioning as a system engineer, as an automotive engineer. Where will you place the component? How will you display the system? If I reduce the cost like the dielectric man reduces dielectric cost and end up in a disaster, what would you do? If you are to innovate and do the knowledge generation, you cannot just wish away the earlier prior art. You have to see what value they are adding. So now we come to the open discussion. Okay, you are taking.
Excellent. I hope each one of you have more questions than when you came to this session, and that's the whole purpose. You saw through several examples the dependencies of decisions that we make, whether architectural level decisions or supplier level decisions or interpretation of requirements, and how any of our assumptions can lead to, either failure of systems even before it reaches a customer, or failure of systems when it reaches, when it's already being used by the customer. And each phase has its own disadvantage, and we need to leverage systems engineering more and more so we can identify those issues much earlier in the life cycle. So with that, I'm sure everyone here will have a great collective experience, and that's what we will do in the next 15 minutes in a breakout session. Let me quickly share with you what we will do in the breakout session. So if I can quickly share my screen.
I should stop sharing?
No, that's okay, sir. So as you can see, we will break out into 4 groups, and we have 4 moderators. We will have 1 moderator in each room, and the moderators will facilitate the discussion. Essentially, we will give out this link to all of you. And in that breakout room, we would really like you to, do this both individually as well as a group exercise. Talk about a top opportunity pain area that you have worked in the past or currently experiencing. Identify which phase you are observing or have observed that pain area, and what you could have applied. Now, with several examples shared by Sir in different phases of the development cycle, and even when things got identified later, there were several cues as to what we could have done. So, now relooking back, like sort of reflect and see what strategies you could have applied, what different approach you could have taken. And it could be as simple as get the supplier in the conversation, right? Or read the requirement, or question the data sheet that you are receiving. So any of those could be featured here. So so all the moderators have this link. They will share it with you once you are in the room. So allow me a few seconds, and I will set up the breakout rooms and and then we will quickly break into good discussion.
Hello everyone, can you hear me? Yes.
So looks like many of you are not assigned. Did you not get the room assignment, or maybe because you're joining from the browser? Is that the case?
They are analyzing all their statements that they are having all 1 year GST tax according to their judgment. What credit limit they should assign.
Atmanand, Niranjan, Bharati.
To issue some credit for these retailers. And how that is current amount of credit.
Chetan,
Yes, your question.
are you able to join a breakout room?
So that is charging some transaction fee. Then there will be the transaction like payment charges. So bank is getting few cut out of those one transaction from south. Yes,
Ashish, Chetan,
we direct the balance. HDFC IC and whenever
Ranganathan, Chetan Kulkarni, are you able to join the breakout room?
this credit partners facility, there will be some charges which we go to back. Payment charges.
For those of you who are in the main room, I'm pasting the link in the chat so you can access that and fill the form. And we'll use that for the discussion once the breakout session ends.
Which eventually bring market size up to 6.68 lakh, which is going at 10.9%. And if you talk about the global agriculture, only
Okay, welcome. Welcome back, everyone. I hope you had a good discussion in the breakout room. You were able to fill the form, document your discussion through the form. If not, I've still pasting it in the chat so you could utilize it. I'll now invite the breakout room moderators. If you would like to share, one very interesting area, that case that you discussed, and that will be helpful for, for everyone here participating today.
Hi, this is Ajit, and we had a very fruitful discussion, and there were mainly the points discussed around requirements, and a very good real life case was discussed. I would encourage Shri Priya to discuss that for the whole group. Shri Priya?
Hello.
Yeah, go ahead, please.
Yeah. Like Mr. Ajit said, like I was telling him about the requirements for a multi-model high volume production line project. So wherein we had to deliver products, the same product, for example, for multiple markets which had different regulatory requirements. And some markets asked for features which were not there in the base product. It was an additional brick feature kind of thing. And the brand owners are from the base feature requested for features of the brick features. So which created iterations in the requirements, which resulted in putting in a lot of engineering hours, and we were not able to meet the timeline as well. So this was the pain point that I told him.
So Vishwas sir, this was a case wherein multi-region same system getting deployed in multiple regions, but the
Yes.
customer from different regions looking at different features were asking
Yes.
or continuously incrementing the requirements.
Yes. See, there are many aspects to this kind of case. If you see, recall my case study of temperature. So what we do at requirement phase itself, rather than going ahead, if we go back to the customer and try to complete them through constructive debate, that is one point of it. And another point is, so the discussions which you may have later, can I prepone those discussions to give them enough breathing space to revise their requirement at step one only. That is one. Another thing is we make it an end of line process with different parameters, different regions. And every time a new requirement comes, a rework results, that has to be treated as a case study, why it happened. Okay. It will have a root cause. Why that requirement was missed? Is it that a bigger picture is still not clear? Or this has thrown out some handicap in the system, some handicap in the missing stakeholder. To that level, one has to go and refine your own process like a V cycle. So here the V cycle has to be applied to a big process system. Okay. So the next time you don't reinventing another requirement, another recurring requirement like this. So every such rework is a valuable experience if you decide to dig deeper into it, dig the insights into it, and see what is the root cause. Was any stakeholder missing? Was some understanding missing? Was the system boundary defined wrongly? Like that micro hybrid. The lesson was my system boundary was defined wrongly. At least there is a lesson. So that is what one has to go. Otherwise, one will endlessly keep complaining that every week I am getting a new requirement. So this is really pointing out to some lacuna in our process of gathering requirement, process of generating requirement, and one should not um, exit that requirement phase and next go hurriedly into next phase unless you strengthen all your requirements. And your architecture for manufacturing line is generally these days end of line based, with integrated production management system, IPMS, with lot of connectivity. And to the best of my understanding, these cases are easily managed, that there are multiple requirements and requirement changing on the go. All you have to do is to reprogram your IPMS system and it starts. But yes, I agree regarding rework. Rework will be costly, and every rework is an opportunity for you to improve, and so that the next rework does not. And any such cases, feel free to involve us. We as a team will handhold such cases and try to arrange this situation. Thank you. Did I answer your question?
Yes, yes.
Hello, did I
Yeah.
answer your question? Do you have anything else to say?
Yeah, yes, sir. Yep. Mr. Rajat told that there is some impact analysis.
Yeah.
So
Yeah.
yeah, I would like to hear about that as well.
Yeah,
Okay, thank you.
I just to would like to add to what Vishwas sir said. There are two concepts, Shri Priya. One is 150% model or 150% requirement. So, I would create a super set of requirements, and then only leave it to variants to pick which requirement to go where. Okay. So if later if a customer says, for some X region, new requirement from Y region applies, I already have it considered in 150% model. What I have to just do is change the variant. That is one way to look at it. And also the other one is, now if I'm limited with the actual implementation capacity, the controller cannot take more or my models cannot take more, then in that case, you got to show what is the impact of adding new requirement going to be on the software or on the hardware and overall system. And that is where different types of impact analysis come in play. The outcome of an impact analysis is whether you want to, whether that new requirement fits. If it fits, then what is going to be the other areas that you will have to touch base, like, whether if whether you have to also look at diagnostic, whether you also have to look at some of the hardware abstraction layer components. So that we general case, we don't estimate, or we leave it to assumptions, and which cause more time consumption and delays than our estimate. So once we are able to map requirements to these different software components in an architecture, we will be able to show it clearly to the customer that by this one change, I will also have to undergo and do these 5 other changes as the impact percolates, and hence I'm going to take 3 more weeks or 5 more weeks, blah blah blah. Okay, so that becomes a more educated and managed change with the customer, rather than leaving a customer unhappy. Okay.
Yep. Yeah. Got it.
Yeah.
Thank you.
So there are different techniques for doing all this. So post the webinar, you can get in touch with us, and we can have a discussion around that, detailed discussion around that. Okay.
Yeah. Yeah. Sure.
Thanks, Nitya.
Okay, excellent discussion. I think that also sparked multiple dimensions of looking at the pain area at hand. Anyone else, Tanmay or Rudraj or Anurag, would you like to break up an interesting discussion?
Yeah, actually, two of my breakout room members had some peculiar problem to their respective domains. One was from Christy. I hope he's online now. And the another was from Nitin Jain. So maybe one of you could quickly discuss your problem, please. Thank you.
I
Nitin,
don't
maybe you can
see
go first.
Christy. Yeah, I don't see
Yeah.
Christy, but maybe Nitin, would you like to share?
Yeah, hi. Hi, sir. Nitin Jain here.
Hi, hello.
Hi. So the issue with this requirement point of view is that there are German companies who have for the small product. Currently, I'm working on the HVAC system of automotive. So they have defined the plenty of records. There are plenty of documents, whether we consist of functional safety or any other standard document. So getting functional specs or getting particular specs for the product is sometimes difficult to understand, for from which when we are designing system requirement specification, whether we are going to the system architecture specification from the customer requirement specification. So in that case, how things are handled, how we
Yes, I will take this up. Plus, let me understand your question that who was your client? Automotive.
Audi,
Uh,
Volkswagen.
okay, automotive. And the exact point was their requirements were not really elaborate, correct?
Not clear that much, and there are
Not
plenty
clear.
of document, but
Okay, okay. To understand this, first you have to touch the bigger picture. You have to, like the tractor. Hmm. The tractor man had
okay.
said 85-degree, but then we went into bigger picture. You understand what is the intention of that OEM, what value OEM wants to add to his end customer, which is the vehicle user. Hmm. Generally, OEMs have multiple motives. Motive A will be cost reduction. Motive B will be driver comfort enhancement. Motive C will be fuel consumption reduction. Motive D will be driving pleasure. Okay. So one has to understand what is the motive, why this picture getting added. That should be clear, for which you have to touch the bigger picture. If not, you can discuss that you must have a business motivation behind this project. That has to be very, very clear to all stakeholders on day one.
Okay.
And once you know the business definition, you put yourself in the shoes of OEM engineer. In my
Okay.
opinion, tier one engineer is well versed with many subsystem and in a better position to put himself and articulate the requirements which make sense to multiple stakeholders. Once we know, for example, this micro hybrid. If it is given to a tier one, the tier one will understand the bigger motive. So bigger motive here is to reduce fuel cost of my customer plus enhance driving comfort. So against that, then I can come up. Once I know this, I am in a position to articulate a requirement. Suppose you don't understand a particular requirement, say temperature, or you find a particular requirement is missing, like starter motor life is not given at all. So you can, once you know the bigger picture, you are able to imagine. The problem is we don't go for a bigger picture. We rather go for a smaller picture and in a pseudo agility manner and start working from next day. And then we understand I am working, but I am not really clear what is it I am achieving. So
Understood.
this is the real thing. And this is where we in Blue Kai will hold your hands. To all the entire audience, you highlight, escalate that situation to us. We will be your extended arm and try to throw light on the situation with our skills, system engineering skills.
Okay.
Thank you.
Understood.
Thank you.
All right, interesting discussion. The floor is open now. You could either share something that you were documenting in the breakout room, or if there's any other open question that you have for Vishwas sir or for the Blue Kai team.
Hi, this is Sanjeev here.
Hi, Sanjeev.
Yes, yes.
We are working on product development, and the product is already into SOP. for certain vehicle programs, and the new programs are coming up for which the same product is taken as base and then new features are added. And so at the same time, there are variants. And I wanted, like, I see that SE was not fully applied for the base product. And now if I have to introduce SE, what would be the right approach? Because already the product is in place already in SOP, and there are upcoming projects with a lot of significant new features as well. But then we have to start somewhere. So I just wanted to understand what would be the we do reverse engineering of SE artifacts, or we again go back to stakeholder and follow the entire SE process independently and then compare. What would be the approach suggested?
I will take up this question. You say that your product is already on the road, and now you feel that AC is to be taken. Very good question and very good intention. The first, now that it is on the road, you can make your system metrics, performance metrics for the product. This can be one system engineering metrics, like from the overall system point of view, like time to market, then number of field complaints, the flexibility in terms of future expected feasibility or scalability, in terms of future expected modifications during its life cycle. These are a kind of system engineering metric you make and evaluate your current product. Then you will come to know the gaps and handicaps, where you have performed poorly, where you have performed just average, where you have expected the expectations. Now your AC needs to be applied to strengthen your handicaps. And suppose you feel that the recurring field problems is a nagging issue, you can have system engineering on that, for which anyway, as I said earlier, you have to see the bigger picture, like that EGR controller, it is a product. And of course, AC was not fully applied, and that is how there were so many naysayers. But then we applied only for that handicap there, and we are able to successfully wriggle out of the situation. So now, rather than repeating entire AC cycle, it is never too late to make a performance metric analysis based on firm system engineering principles to evaluate where you are. Had you applied system engineering, where you would have been, and where you are, where are the gaps? And does it make sense to plug gaps now? What are the cost benefit analysis of such an exercise? That to critically evaluate. If you want any help, we are there to hold your hands. Let us know. We will come and discuss a specific case. So did I answer your question?
Yes, thank you, Vishwas sir. I think it was.
Hello.
So we'll come back.
You will come back to me?
Yes. I said thank you.
My phone number. My phone number I will give you. I will type. He will type. You come back to me, because this requires a detailed discussion. I have given you the direction, but this requires a detailed discussion offline, which we would be glad to connect with you.
Yeah, I think it's a very, very pertinent question, Sanjeev, that you have asked. It's very common, especially when we are working on legacy systems or we are working on systems that have already been launched in the market. There is no, like sir also mentioned, I'll re-emphasize that any time is the right time to start implementing systems engineering principles. But that does not mean, if you're already familiar with INCOSE, that does not mean that look at the INCOSE guide of systems engineering processes and implement all. That's not how it works. We need to identify where the complexity lies. You want to address the complexity. You want to address the maximum risks where they are. and have a starting point. Like sir mentioned, one of the ways is to establish performance metrics or for your system, for your project, and then have a goal. And what we can help you is establish that roadmap to go from where you are today and where you would like to be. Especially in this case, you're considering new products that are going to get added in the same platform. So, and you don't want to carry over the gaps of the previous version and just do band-aid fixes on that, right? You want, and it's very good that you're already realizing as a team, as an organization, that you would like to look at what it is, and rather than doing band-aid fixes, look at it holistically and bring those improvements in a systematic way. So I would say, even if not done in the past, now is the excellent time to adopt some of the systems engineering principles and methods.
Right, agree. Thank you.
Thanks for sharing that. More questions?
One more question.
Okay.
One more question.
There is one more.
There is one more question.
It's in the chat here.
There is one more question.
So he's asking, generally we take few weeks to correlate the result with test data. How effectively we can use systems engineering in related to small subsystem?
Yes, I want to take.
I want to take up this. See, CAE, to the best of my understanding, or from team point of view, is not just the backward engineering. What you are doing, backward engineering, the reserve, the product is out, and you are testing the correlation. It is also the front loading, forward engineering, which we call through simulation, modeling. We have to predict what our implementation is going to result into, what would be our outcome, and do the fast iteration at the start of the V cycle. And that is where we would be able to do our homework early. Front engineering, like the mirror case. In the mirror, if the text was given more than the mirror, so today if I have to do the electronic throttle, I will not do the backward engineering, like wait for somebody to die and then start analyzing our testing. No, I would do my analysis very early, simulation, and then see that if in my logic both the inputs, brake and accelerators, are on, how my MATLAB model is going to behave, and know the answer on day one. Okay, so this is also in a way CAE. Or some other counterpart in your team member has to predict how it will behave, and then only it makes sense to verify the test data. That is how you have to shorten the time duration when the pain points are exposed early in design cycle, and not wait. Okay.
Yeah, and I'd like to add that, especially with respect to modeling, it's of big value to create low fidelity system models where you can feed in some very important parameters to understand if they change, if you're going over the requirement envelope, or you're trying to explore how the requirement envelopes can, or the constraint envelopes can expand. You utilize that system model to do it. The systems engineering happens at that abstract layer. It does, what you're doing at the subsystem level is more of detailed engineering, and where you need expertise, where you need detailed high fidelity models to do your simulations. But you need to feed back your simulation results from the lower layers to this layer above at the system level. So think of it that way. Each layer is important. The detailed engineering is also important, but I wouldn't qualify that as doing systems engineering at that level. It's more, as long as you're feeding the data back into the overall system model, where you're able to see the holistic behavior or changes in the system when you change the parameters.
Yes, to add a couple of lines to her, take microhybrid example. See, that starter motor person did not resort to any CA analysis. He being expert of his own product, he was able to mentally simulate everything and upfront tell you, this is not what my product is designed for. This is forward engineering. Every time you don't have to go to CAE, wait for a failure and CAE. So as a forward front loaded system engineering approach, what I would do, I would treat this as a new vehicle, revised design of a vehicle, and bring on board all the tier one suppliers and tell me on day one, this is how I am going to have my vehicle. Do you think I can carry forward your aggregate, or do I need to revise it? All they have to go is to their life cycle specifications, their duty cycle specifications, and find a gap by just using your eyes, no computer required. So on, so many times off. With this, I have so many more times on and off. So then I don't need really CE tools. I need plain common sense of a product expert. So this is how a system engineering approach works. Okay, thank you very much.
All right. More questions, comments? I'm just trying to share a link in the chat. Sorry.
You are all most welcome to continue the dialogue, continue the interaction, because it is only start of. It is only a start of journey. So you are all most welcome to be in touch with us.
Thank
All
you.
right, I have shared a feedback link in the chat. Please take a few. It'll hardly take less than a minute. Please do respond. It will help us bring more programs in the future that interest you. Today it was more geared towards automotive professionals in automotive and those who have interest in automotive industry. It's 5 o'clock. It's the end of the session. I thank you all for staying till the end and interacting. Hope this was useful and a good learning experience today. We definitely really learned a lot through the discussion. So thank you for sharing your experiences and hope to stay in touch. I'll bring up back the slide where we had our contact information. So do stay in touch with us. You can contact any of us. You can visit our website or you can reach out to us through email and LinkedIn. Thank you, everyone. Stay safe and have a great week.
Thank you. Bye.
Thank you. Thank you for the session. Thank you very much. Thank you. Bye-bye.
Thank you. Bye.